but it's called unique, and that will change the order, the contents that we're sending through. Wait, no, that's sort. That's another program. Unique just shows the unique line. Hello, and welcome back to the channel. My name's Ash. I'm 27. I'm a cybersecurity enthusiast and educator. Here on the channel, we go over everything capture the flags, hacking, and cybersecurity related as we go on our learning journey together. If that sounds like something that you're interested in, consider subscribing and hanging out with me, and we can chat some more. On today's video, we are going over more hoppers or roppers, the computing fundamentals course. Currently, we are up to the Linux command line, so we're finally going to start getting practical and hands-on. The first section here is talking about the Linux certificate. So look at this as our reward for all of this hard work. Not only do we get some awesome skills, we get to better ourselves, but hey, we get a little certificate. So that's cool. So next up is operating systems. And here we're posed with the question, what is an operating system? Damn, that's a good question. What actually is going under the hood of our computers when we're interacting with it, like right now? So here we're introduced to the term abstraction. So it's not just a word in computing or cybersecurity. So it's sort of like pulling back layers of complexity. And the point here is this course itself is abstracting away from the things that aren't necessary to us right now. Because for us to like understand how a processor works at the lowest level, it would honestly just make us cry. Like there's no point right now to understand such deep that maybe even in our entire career, we don't need to go that deep, and that's okay. So in the same vein, operating systems, we can sort of abstract away from the requirement for the end user. So just for average Joe, the operating system is really doing everything for us. It's talking to our hardware, it's making sure that our programs are running, and it's getting the required resources to run what programs, and it's doing that all multitasking. It's doing everything for us right now. And the whole point is that we get closer, we go start understanding those layers. And that's what I love about this course is it starts like peeling it back step by step for us. So we don't need to worry about what's going on here right now. And I love that the first word describing this graph is simplified. Ah, yes, simplified. But I guess let's quickly going over it. We've got like the system purple, networking yellow, storage, memory, and processing along the top. So these are sort of our categories there. And our operating system with our layers going down in the orange here, it's controlling all of that for us. Our virtual file system, understanding our different file formats, understanding our different networking protocols and where to send packets. Yeah, it's honestly, it's a lot. So to define the operating system, it's the interface between the end user and the computer hardware. So us, this is like how we interface with the computer. Makes sense. So hardware is generally controlled by something known as firmware. Firmware is code built into the electrics that tell them how to run as individual components. So I don't know if you've ever had to update firmware, like this webcam that I'm using, it's included software that has the firmware in it and it updates like for me. Maybe you've had to install firmware for your router or something like that. So another way to think about it is the firmware is the operating system for the hardware. Take a step back, hardware and software. Make sure we understand the difference there. Hardware is physical, tactile, we can touch it. That's our graphics card, that's our processor, that's our case. Like that's all part of a computer, that's our hardware. So code that is directly built into the electronics themselves is known as firmware. But on a normal computer, it's not considered part of the OS we interact with. So we have a nice little layer system for us here. The user, that's us, interacting with the application. So right now I'm in a browser, going to the operating system, which right now for me is Windows, and going down to the hardware, which is my beast of a machine. All right, I'm gonna read this out because this is something that I get wrong like all the time. Coordinating individual hardware components is the kernel, the core of the operating system, which coordinates those individual components, RAM, hard drives, so that computer can run. Software, as we think of it, is the code that a user interacts with. But the kernel, even if we never interact with it directly, is still software as the core of the operating system. Running on top of the operating system is more software, are what we think of as processes and programs. A process is a program that's running. These user processes interface with the operating system, which then do all the work with the kernel to ensure the process works properly. I use operating system interchangeably with kernel, which is wrong. Something that I need to like have better burnt into my brain. The kernel is the core of the operating system. It's within the operating system. The operating system, it doesn't talk directly to the hardware, but the kernel, part of the operating system, is what talks to the hardware. Okay, and that sort of takes us nicely into the responsibilities of the operating system. So I'm gonna sort of wave over this a little bit because I feel like most of us understand the different parts of our computer, but I'll quickly just touch on them. The CPU, I think about it like the brain, circuitry which executes instructions that we give it, RAM, random access memory, the chips that provide fast temporary storage. So it's sort of like the part in our brain for short-term memory. Input-output devices, or I/O, so hard drives, storage devices, whether they're mechanical hard drives, external, SSDs, M.2 drives, that sort of thing. So it's sort of the long-term storage, the other side of our brain. I don't know where the right part of our brain is. So mice, keyboards, so that's like the layer of peripherals that we interact with, obviously. Monitors, yep, like what we're looking at right now. Cool. And this leads us nicely into the next section. So the actual role of the operating system, what they're doing with all these parts. So the CPU and the operating system is managing our processes. So if we were to open up like our task manager or a utility such as that, we can see all of the processes that are running on our computer right now. Also memory management, so our RAM, so it's allocating the amount of RAM for short-term access to other processes right now. So I'm running a couple of instances of OBS to record this video, so that's taking a lot of my RAM and my processor, and also quite a lot of GPU. Same with our devices, what we plug into our computer. So I'm running like a webcam, some lights, like all that sort of I/O device. They all get managed by our operating system, our file manager, so on Windows, File Explorer, even security, so it's running like our antivirus system. So like by default, we've got Windows Defender, but you might be running like a third-party solution. Logging and error detecting. So if we look up our event viewer in Windows, we can see all our logs for like our applications, for our security and that sort of thing. And then lastly, like going back to our task manager. So just general system performance, like what we were looking at. So like even our network traffic, our hard drive activity, memory and processor, all that sort of thing. So again, operating system's just taking care of all of that for us. So next up is families. So sort of the major families of operating systems. So I've talked a lot about Windows because that's what I'm on, but we're going to talk a lot about Unix or Unix-like operating systems, which is Linux. And this is the most popular operating system for servers. So you might have heard of a couple of these: Ubuntu, Debian, Ubuntu's based on Debian. Android, which is possibly running on your phone right now, Raspberry Pi, if you've heard of them, Chrome OS. So these are all based on this one family. And we can see a slightly pixelated graph of a timeline going back to 1969, the first Unix operating system, and we can see how it just has gone crazy from there. Was it 1992 that Linux was around? Somewhere around there. And it's just, yeah, gangbusters, all different versions, quite overwhelming how many there are. And then Windows is less interesting, but still worth pointing out. So yeah, based on MS-DOS from 1981, going up to Windows 10 or Windows 11, and heck, Windows 12 is around the corner. So great. So the next section is first assignment. So we have our first official assignment, where we've got to answer these 4 questions, and our resources is Google, so just the good old search engine. What is an operating system? Describe an operating system, and world's most popular operating system. I think it's Android. But does that mean Unix, or because everything's based on that, or Linux is then the most popular? What are the top desktop operating systems? So these are all some pretty easy questions that we can go ahead and research. All right, next up is the Linux history and Ubuntu. So quick history of the Linux kernel. The kernel being the lowest level of the operating system, and as we know, interacts with the hardware, and we could call it the heart of the operating system. So this means that the kernel is written and then the operating system can be built on top of that. So Unix is considered like the parent or the ancestor of Linux, and Unix was written by Ken Thompson and Dennis Ritchie at Bell Labs, and was considered the first most modern operating system. Look at these legends. And then in 1991, I was close, I thought it was 1992, but in 1991, Linus came along and wrote the Linux kernel. And I believe still to this day, he's actively involved. And it is free, open source, highly portable. And this then paved the way for so many more operating systems. And it's one of the big reasons why we've got just so many today. Which brings us to a very popular distribution, which is like a flavor of Linux, called Ubuntu. Ubuntu is by a company called Canonical, and they are a group of developers from 2004, and they're still actively releasing versions, and they also have a server version. So if we go to ubuntu.com, we can download it from the website. So Linux is open source, but when a company comes along, uses that open source like Ubuntu, and then makes their own flavor of Linux, and now it's their own operating system, it doesn't necessarily mean it's still open source. Like Ubuntu is actually closed source. But you can go ahead and you can go download the latest version of their desktop or their server. In fact, we'll run through this together and we'll set up our own lab in this course. So if you want to hang around and wait for me to do it, awesome. If you want to go ahead or you've already done it, then that is totally fine. And I like this point that we've got here, like about deeply caring about your operating system and your programs. That's definitely something that I've got caught up in before, and I think we're all guilty of it to some degree. Just use whatever is the best or the easiest thing for the task that you're trying to do. And like for us, just learning Linux, Ubuntu is a great place to start. You don't have to use Ubuntu, you can use whatever you want. But if you're not familiar, why not just use Ubuntu and we'll use it together. Let's just read this to myself. I don't want to act it out, but I mean, you can read. It's just like the rabbit hole of Linux. Actually, this reminds me of somebody who they started. There's like a project where you can just like make your own kernel. You can follow along and like make it from scratch. And like, I remember telling this professor like, I don't think you need to do that right now. Cause like, he's still just learning Linux. His brain was just like, no, I have to go as low as possible and like build up from there. Just be careful. Just be careful with how deep you go, how fast. That's all I'll be saying. If you can do it, fine, cool. You can go for it, but I'm gonna stay at the easy levels, just personally. Great, so the next section is called shells. So this is sort of another concept that we gotta think about. Both Linux and Windows have CLIs, stands for command line interface, that we will be operating with as power users. Ooh. So like right now, I'm using a mouse and keyboard, you probably are too. And when we're clicking around in our GUI, graphical user interface, we have a visual things, stuff that we're clicking around on. I don't know if a GUI is considered a shell, like I've always said it is, correct me if I'm wrong. This is just another way of interacting with our computer. So Linux, there are a variety of shells, but the most popular one that we'll be using is Bash, which stands for Born Again Shell. Windows, you may have used, there's CMD or command prompt, PowerShell, and more recently, we have WSL or Windows Subsystem for Linux. So you can actually get Born Again shells, you can get Linux shells now running natively in Windows, which is quite cool. So if you're on Windows 10 or 11, I've just gone and opened Windows Terminal, and I've set PowerShell to default, but we can also have a command prompt or CMD. We can also go and run these WSLs, which you can install from the Microsoft Store or directly from the Microsoft website. So we can run Ubuntu. This is natively running, and we can even get like another distro like Kali, which is built on Debian, similar to Ubuntu. But this is actually running a different shell called Z shell. So just to get used to shells and using the command line, let's go over and visit the online shell. Great, so once that's loaded, we can use the ls command and we can list out everything that we've got in there. Next up, we want to cat out our readme. So we're gonna go CAT and readme, and I'm just gonna hit tab to autocomplete. So if you're typing something in and there's something that's probably gonna fit what you're typing, you can hit tab. So if we hit enter, that's just gonna list out all the contents or concatenate, join together the contents and display it out for us. So it says some test, compile hello C with GCC or TCC, and we can run this. So it's telling us how to run this command here. So it seems super complicated at first. Like as you get more used to using the shell, I can see like this is the command that we're running. This is now again against the file. So we're passing that file through this command, and we've now with the -o, that's like a switch or a setting, and then we're giving an argument through that setting. So let's continue with what it says. In that file, you will find 3 commands to run. 1, 2, 3. Use cat hello C to read the contents of hello C. So cat hello, if I hit tab, but this time there's a hello.c and a hello.js. So it stops at the dot and then it's asking. So if I hit tab again, we're actually seeing your options like, hey, what do you want to go to? So for this, we're going hello C. So we can concatenate hello C, and we have a C program. I don't know C, I'm not a programmer, but by this file ending in .c, that's telling us it's written in a particular language. Like .txt is a text file, .js is a JavaScript file, and .py is a Python file. I'm not like particularly familiar with JavaScript either, but hey, at least we can tell what's going on. What do you expect to happen? Well, like we just saw, it concatenated the output. So this didn't actually run the program, right? Like we didn't run hello C. We haven't actually executed that program. Instead, we just said, hey, can I just see what's inside this program, what's inside this file? Use the first command in read.txt, so we can copy paste that in, but we'll type it out, to create an executable named hello. So this is gonna compile, is that the right word? Compile, interpret? I think it's compile. So gcc hello.c, and then we'll go -o, and we'll pass through hello. Hit enter, let that run. So remember, we are using a remote system here. This is not running locally on our system, so it might take a sec. And that creates an executable. So if we hit ls again, we'll see that we have this green file now. And to execute that file, we've got our instructions here. We need to put // So it seems really confusing and weird at first, but that's just how it's done to execute a file. Okay, so it's going to tell us in this directory, go ahead and execute that, and that's gonna do what the program does. If we go back to this program, all it does is just prints out hello world. Awesome. So we have our next assignment to go over. So there are a few questions there based on what is going on, what we just did. So in your own words, describe what ls command does, cat, gcc. So all of these things, if you're unsure, have a man page. So man stands for manual, just like when you hop in a car and you're unsure how to use it or whatever, you get to the manual. That was probably not what who jobs at a car, it just looks at the manual. I don't know, but you know what I mean, there's manuals in cars. Yeah. So if we go man, gcc, man is not actually installed. So sometimes there is like a -help or a -h, and for whatever reason, it's just not there. But if we go to man7.org, we can actually search here. So it's online and we can find GCC Linux manual page. Compiler, I was using the right word. So project for C and C++ compiler. So some programming languages that I don't fully understand, but they need to be compiled so that they can run. Some programming languages don't need to do this, like Python. Alrighty, next up is learning the Linux commands, and we've got some important notes about memorization. So don't worry that you don't remember how to do everything, just take your notes, do your best. Off screen, I've got like a ton of notes from when I've last gone through this course and like this section. So don't take me as an example just because I've done this once. I take notes heaps, okay? And if you want, let me know. I can share my notes with you. I'm like trying to reorganize them off screen, like when I go through this. But the whole point is that you can just look things up. Even if you don't take notes, you're not a big avid note taker. I mean, probably would get a little bit better at that personally. But otherwise, you can just Google when you don't remember something. You can just look things up, so don't stress. And like anything, the more that we do it over and over again, the more that like we'll remember it and it'll slowly ingrain in us. So don't stress too much. So the first resource is those man pages. So that's what I was actually talking about earlier. And there's man 7. So if you just Google like man page for a program like I did, like you'll find that website. Okay, so but bookmark it if you want, like that's fine too. There are also cheat sheets. That's broken. Yeah, we can just look up cheat sheets, and there's a ton. Like I don't know, I don't use cheat sheets. I don't know if it's like worthwhile. I always find them a little bit difficult because I can't see everything, so I find myself like scrolling. I might as well just like Google the command that I'm trying to figure out how to use, or just Google a phrase like, how do I do this again? Otherwise I'm searching through this anyway. So I don't know, I don't particularly love cheat sheets, or maybe I just haven't found the right one. There's also explain shell. This is one that I should really bookmark and use more, but I just forget to. Let's try GCC. So that was really fast. Like we just quickly get like what it does. But this is the difficult thing, and I think we have a little bit in this course, but like some of the explanations, like they're not written in the most user-friendly way for us, like as beginners. Like they use a lot of terms that we might not like understand. I mean, like ls is fine, list directory contents, but you could argue even directory might throw off like a beginner. Concatenate files and print on this standard output. Like I'd argue that's hell confusing. Like that's super confusing. Concatenate, like what's the standard output? Like I know that like we're gonna learn about this and it's gonna make more sense as you go along, but just in the beginner phase, like I wish there was like a dumb explainshell.com. I feel like that would be great for us. Like just learning. But yeah, I mean, it gets complicated pretty fast. Like look at these examples, like what is actually going on? I have no clue. What is this? Even here in the course, about 50% of the time the commands are common enough for me to do it off the top of my head. 20% of the time needs a cheat sheet. Another 20% of the time it's Googling. 1% of the time it's using a local man page to figure it out. Generally, like we'll always have the internet, like we'll always have Google, so we can like look stuff up, so it's not like a big deal. But like I would personally say maybe increase like the use of man pages, because it is a useful skill. Like not that I've ever been in a situation that like I can't just Google something, but hey, maybe that will happen and you're not used to using man pages. I don't know. But for the Googling, how do I do blank from Linux command line? And I think this is like trying to find the right article, the right Stack Exchange forum post. It can be a bit tedious, I think. But again, the whole main takeaway is like, don't stress too much. All right, so next section is command line basics. So let's jump back to the JS Linux browser shell. I'm just gonna type the command clear, and that's just gonna blast that terminal. So we've got a few basic commands for us to run. So we've got who am I? So that's going to tell us the user that we're currently logged in. Oh, we have root access. That's cool. The next command is pwd, which stands for print working directory. Now, I can't remember if it was this course or maybe it was a Cisco course, but apparently print working directory is from the times where there was not a digital terminal, but a physical printer that would print out, like literally print out on paper, the working directory of the computer for the user. I don't know if that's true or not, but that's nuts. Long before my time. But anyway, so that's like the folder that we're in. So the term directory just means folder, like it says here. So we've already done the ls command, which remember is listing our contents in our directory. And there is a -l for long. I always think that it just is another L for list. So ls-l, and we can see the output and how different that is. So all of a sudden we get all these dashes and R's and W's and X's. We get these numbers, we get root all the time. We get more numbers. We've got some dates there. So like it's just a lot more confusing stuff. But it doesn't have to be. Actually, this is all very useful. And if we just break it down, and I think this is where like I found Linux quite overwhelming and sometimes still do. But like we just see a lot of information. It can just sort of like be a little bit overwhelming for our brains. So if you're like me, just take it slow. Like so like line by line, there's nothing wrong. Total 36. So that's kind of interesting. Why is there a total of 36, but we can only see like 5 files? So we can actually go ls-la, and we can see a bunch more. So this time we've got a total of 60, and we've got all these dots before some folders. So these are hidden directories. So I don't know if 36 is like the amount of bits or bytes, so it's definitely not the amount of files. So I'm not totally sure exactly where that number's coming from, but we can do a few other things. So we have an mkdir, so make directory. We can have Linux playground, type that in. Usually when we don't see anything for the terminal, it's like a good thing. Usually if something goes wrong, we'll get like an error message. So in this particular shell, we do have some color coordination for us, which makes it a little bit easier. We might not get the nice fancy shells in every interactive shells, I mean. So we can tell that this is a directory a couple of ways. One, it's blue. If we run ls-l again for long, at the beginning of this line here, we have a D, which stands for directory. If it's the beginning is a dash, then it's just a file. There's also other ones that I can't think of right now. S-A? Is that it? Anyway, so we've made a directory and we can use the other command cd for change directory, and we can type L, and I'm just gonna hit tab and enter. We get in there. So already you can see how you can speed up. I think something that like you might think it, I know I did when I first started beginning, I'm like, how is typing faster than using a mouse? Like didn't terminals and using a keyboard to interact with a computer, like wasn't that outdated by the mouse and a visual interface? Well, like yes, it was like an improvement, but like think about like for home computers, people can't just type in a terminal without anything pretty. Like that's never going to appeal to the masses. So hence the mouse and the visual interface. But that doesn't mean that like typing like this, you actually could become like a legit power user. The more that we do this, you can do it a lot faster. But I mean, it just does take practice. So we can go ahead and list out our contents in the file that we've changed it into. And you'll notice that our prompts has changed once we did cd into that directory. So this tilde is our home directory. So there's a few just like, somebody just decided once that this symbol is going to be the home directory. So if you're ever lost in a terminal, if you just go tilde, oh, that's a backtick. If you just go cd tilde, no matter where you are, that'll just take you back home. So if we list out, for example, is that a forward slash? Man, I always get confused between my slashes. If we just list out forward slash, this is going to be this is like the root. This is the most top level of our system. So, I mean, we'll get more into this later in the course, but these are just some of the, I don't know if they're called symbolic links or no, that's something else. They're just commonly used symbols for different things. So this also is like a directory. So if we change directories into our home directory and then into our Linux, oh wait, we're not in the home directory. If there's a user, the directory will be in there, but we're actually root. So our directory is ut, and then our Linux will be in there. Wait, where is it? CD root, yeah, we're in roots. Can't cd to root, oh, because I'm already there, I didn't change. So if we cd up to the root, and then we go root Linux like so, then we're back in. Yes, so much faster. I'm a great demonstrator. Okay, what's next? We've got echo hello world. So echo is another command, and we can type in hello world. And that's just gonna print out to the standard out or the terminal for us to see. This seems like really silly, like why is this even a thing? But trust me, it makes a lot of sense down the road. If you just want to quickly put something in a file like this, we can just go echo hello world and just like quickly chuck it into a file, number1.txt, that has both created a file txt, and it's also, if we just cat that out, it's put hello world inside that file. So, you know, again, ooh, like, why don't I just make a file and copy paste it in? Like, why do I need echo? There might be a really long file, like maybe it's like a log file and you just need to right at the end. So this is called a redirect. So this will overwrite the whole file if you just do one crocodile mouth, but if you do two crocodile mouths at the end of file1.txt, and then you just hit up arrow, by the way, if you want to cycle through your commands. So up, if we cat that out, again, you'll see hello world. We put that in once. And because we use the double, the crocodile mouths, the two, chomp, 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 then it puts goodbye at the end of the file. But if we just put goodbye with one in file one and then cat it out, you'll see goodbyes only there. So that just overwrites. So just one creates the file and just overwrites everything. So gotta be careful. And there's no easy Control Z. When you've stuffed up, you've stuffed up. Or at least I think so. If there is a Control Z to Linux, please tell me. Maybe there's a program to do it. I don't know. Yeah, so like it says here, you can put goodbye in there. So next, making a copy. So CP will make a copy. So file one, and we'll just type out, oh, my keyboard is stuffing up, file2.txt, and then we list out. So now we have file one and file two, and we can go ahead and use the remove command, rm, for file 1. And again, we can list out and then it's gone. Voila, it is gone. So we've already looked at the output by using the long, and this is sort of breaking it down a little bit further. So we saw the D means directory, so we covered that. Dash means a normal file, but only in the beginning. Okay, these are all groups of 3. These are called permissions. Again, looks so confusing at the beginning. None of this made sense to me, but once you're used to it, it makes a lot of sense. The next 9 bits are permissions. So there's read, write, and execute. So the first 3 are for the owner. So whoever creates the file, the creator gets read and write access so that you can't execute a .txt, so there's no execute. Then the group gets read access just for this file. I'm just giving an example of this file. And then others, so anybody else. So these are talking about users and groups. So anybody else on the system, they can read this file. So we can change all these permissions using the change modification command, but we're not going to get straight into that just yet. Just a little bit of a breakdown of what is yet to come. If none of this is making sense, like, don't stress too much. It'll all sort of, like, honestly, I've had to like look and learn this stuff like multiple times for it to start making sense. Don't stress. So the next number tells us how many hard links there are in the file. Gotta be honest, I can't remember what hard links are. And then the next is the username, who owns the file. The next is the group, who owns the file. So it's just a repeat, which is a little confusing. It's not like it says group in brackets or anything, but again, once you know, it sort of gets used to it. The next number is the file size in bytes. So directories are always 4096, but individual files should be the number of bytes that make them up. So this is talking about the actual information within the file's data. So the next is the date and time, last modified. That's today's date, today's time. These are not forensically accurate, but are good enough to sort by timestamp. And then finally, the name of the file that we're looking at. So we can also hit Control L. That's the equivalent of running the clear command in our interactive shells. And we can go ahead and use the touch, which will just create a blank file. So I'll just go blank.txt and we can list everything out, and we'll see in this blank.txt, there's absolutely no information. Unlike this copy of file 1, which does have the word goodbye or 8. Question, why is it 8 bytes? There's 7 characters. Is the new line, the line itself, is that considered a byte? A -n for new line? Is that why is there's 8 bytes? I don't know, I should look it up. If you know, let me know. So let's go ahead and make a file 3, and we'll make another directory called folder 1. And we can go ahead and use the move command, mv, for file 3, and go and chuck that in folder 1. So we can list out folder 1, and we can see that that is moved. But if we list out our current directory, it's no longer there. So you can run list and put an argument like I just did. Like, I didn't change directories into folder 1 and then hit ls. If we just want to go back, cd ... so ... or period, whatever you say, that's just talking about the top directory, so the directory above. So I was in folder 1, and then I said, hey, can you change directories to the folder above, which was Linux Playground, and now I've gone up to Linux Playground. But like I did before, I can just list out folder 1. I don't have to move into it. I can just say, hey, computer, please show me what's in folder 1, and it'll do that. So that's kind of handy. And then we can go ahead and remove folder 1. So if we try and do that, it says, hey, whoa, look out. This is a directory. This isn't a file. But if we go -r for recursive, and then we go against folder 1, it'll delete that. Sometimes I've had to use the -f, so I'll have to go -rf for force. Just depends if it's being used or something like that. But just be careful. And sometimes you might see it if you're asking people for help in the Linux community and somebody says, yes, go use remove -rf and then the root directory. That means you're removing everything recursively, so meaning it'll start at the top and it will just delete everything below. So if that's all our files at the very top and it's deleting everything, then you won't have a file system. You need a file system. Props, don't do that unless you feel like it. All right, next up is Bash internal and Unix philosophy. Starting off with the Unix philosophy. So to quote an early Unix developer, Doug Clory. The Unix philosophy: write programs that do one thing and do it well. Write programs to work together. Write programs to handle text streams, because this is a universal interface. Basically, make sure everything's simple and works together, and that's awesome. As it reads here, modern programs don't care as much about these things because they are no longer limited to things like size, processing power, connectivity. But when you're in the terminal world, you are in the Unix world. And to be fair, even modern programs probably should lend more to this philosophy. I mean, we've got so many programs that are just doing so many things, and sometimes they're not really doing anything too well. So I don't know, I think it's a good philosophy. And the other thing is everything is a file, which personally, that sort of tripped me out because I'm used to, like, you know, there's software and then there's programs, processes, utilities, tools, like third party. So like all these sort of terms. And when you think of like everything is a file, like programs are files, the process is if a file is running, if a program is running, your settings are all just in files. Like, it's kind of cool. It threw my head for like a little bit, but the more you think about it, the more simple it is. Keyboards, printers, everything ends up just connecting and looking like a file. So POSIX, I don't really know how to say it. It's just a standard for programs to follow to make it more friendly between hardware kernels, so it's just things can work better together. As it says, there's a ton of complexity there, so I'm not gonna go too much deeper into it right now. But it's definitely something that I see pop up and I always go, man, I should really have a better understanding of that, but one day. All right, so what does all of this mean? So everything in the terminal should speak to each other because everything speaks the language of the text streams in the same way. So we ran echo hello world, redirected it to file 1. So let's just break that down a little bit. This is another thing that like confused the heck out of me when I first did this, but it makes a lot more sense now. All right, let's look at this heavily pixelated image. Okay, so we have our text terminal, which is the keyboard, the thing that we type with. So when we pass echo hello world direct file, like standard in, it's then by the magic of Linux kernel and operating systems in our computer, it then knows, it goes and finds the right program, it goes and does everything for us and looks for the process and then gives us the display, the output. So just jumping back into the terminal or the browser terminal. So we just type this out again. We've got echo hello world direct. This actually doesn't give us our standard out. We've just, by this direct, this little icon, we've actually controlled the standard out, and we're saying, hey, don't give the standard out back to the display. Give the standard out of this program. So the outputs of this program, which is hello world, go ahead and put that in file. And that's why we don't see anything. If we just go echo hello world, now we follow this standard in as hello world, process of echo gets said like, hey, we need you to work echo, can you please? And then the standard out puts back to the display. But this first one we controlled, we redirected that standard output. We said, hey, don't you come back to the display, go to file 1. So we have a fellow student who has written a helpful explainer. When we're launching a program or about to use it, there are 3 data streams like we were looking at, which we can think about as paths: standard in, standard out, and standard error. So standard error, if there's something that goes wrong, that has its own data stream. A user presses letter A on the keyboard, it is captured by standard in. Standard in passes that letter A to the system. The system interprets where the standard out is currently. Usually standard out points to the user's screen, and is the case, the key press is successfully captured and sent to the screen by the standard out. No errors occurred to standard error, so then it did nothing. So it's not just, it's even just down to the letter E, the letter A, like that standard in back. So it's not even when this whole thing, like it's, and the last one, standard error. So I've just ran ls-l against file. File doesn't exist, so I get an error. So this is the standard error data stream that's now outputting to the display saying, hey, you've got something wrong. So we have a next image, which is slightly more complex. So similar in nature to the last one. Keyboard, standard in, program 1 then detects was there an error. If there was, like I had here, it displays it. If there's no error, then the standard out or standard in can be sent. And this is what we did with directing. So instead of just going back to the display, we directed it somewhere else to another program or another file or something else. And this is where we can start to chain together commands. Sorry if this all made sense like straight away to you, but I don't know, this stuff is hard. If you have just been watching, you haven't actually been doing it yourself, I'd recommend just pausing and just do it. Echo hello world and direct that into a file, echo goodbye like we did earlier. It's like really the only way just watching someone do it is not going to help you. Like honestly, watch, pause, do it yourself. It's the best thing that we can do to learn this stuff. So these are called redirectors. So single tells bash to fill in from the beginning, and then 2 will append, just a fancy word for going to the back of the file, end of the file. So how does bash know where the end of the file is? It's a good question. I've like never thought about that. Bash walks through the file or iterates through the characters one by one. And when there's nothing else, then it stops, adds that to an old stream, resaves it as a new stream. And those numbers, like I said, they come in handy. We can also use 1 to redirect an output to a file because 1 is the file descriptor or FD. So if I ls-l against a file, here is our error. Okay, so if I get this error, I can just go put it into something else. And we'll just use dev null, which is, it's just a thing. It's just like means get it away, put it somewhere that we don't want to see it. And we didn't see it that time. So that's pretty interesting. So maybe we have like a error.log file. And if I run a program like this, I just want to put it into the error.log file. So I didn't see it, but if I go ahead and cat out our error.log file, well, hey, there's our list. So you can sort of see how this sort of thing might be helpful, like to log all the errors on a system. And if we want to redirect standard out instead of error to a file, we can use and. Oh, that's actually interesting. I didn't know that. So another thing is called the pipe. So this is like the straight up line on our keyboard, close to the backspace. And this is how we can start to send things together. So we have a command here. I'm just gonna copy paste, don't judge me. Echo cat, dog, sheep, cow, dog, cat, and put it into animals. Right, I can't paste. Okay, fine, I'm not gonna copy paste. Cat, dog, sheep, cow, dog, cat. And we're gonna put that in animals. So we can go ahead and cat out our animals. And then I'm gonna do echo cat, dog, sheep, cow, dog, cat, and put that at the end of animals. So if we go ahead and cat animals out again, we will see our 2 rows. And then lastly, let's just echo cats again at the end of animals. And there we go, that's our file. So instead of just concatenating it like we have, if we use a pipe, so it's going to send this output, instead of just displaying it to the standard output like we're seeing now, it's going to send that standard output through another program we haven't used, don't stress about it, but it's called unique, and that will change the order, the contents that we're sending through. Wait, no, that's sort, that's another program. Unique just shows the unique lines. Unique-H, unique, discard duplicate lines. That's what unique does. So if we go ahead and run concatenate again against animals, so that didn't alter the file. So the file's still the same. All that's done is altered the output, the standard output of our animals file. It's gone ahead and taken that output, passed it through unique, and it's only showing the unique files. Again, might seem super weird, like why would you need to do that? Well, you'll be doing some challenges soon. And yeah, there's some challenges where you need to find like there might be like a billion lines within a file and there's just one line that's only mentioned once. How can you find that, like that unique one line? That's how you can do it. Pass that file through that command. Fascinating. Oh, here's the sort command. Cool. So if we run cat through sort, and that looks the same, but then pipe it through unique. Okay, it still looks the same, but I mean sort, if we run sort-h, it sorts lines of text. So sorts alphabetical by default, but you can do a whole bunch of other stuff. And honestly, every command, like even just our concatenate, like it's got all these different options, which Honestly, it's crazy. Going through our options, there's also another redirect going the other way. So we could sort of reverse things just for example's sake. So if we put the outputs of animals into sort and then pipe it through unique, it's going to say, nope, can't do that. So if we put animals and direct that to send in through sort, but then pipe unique, hey, that worked. I must have spelled it wrong. Cool. And the last command here that's talking about is T. So we run the help command T, copy standard in to each file, also to standard out. So T is command named after the T-shaped pipe in real world plumbing. That's a T-pipe, and that's what it's named after. Good to know. I think I'm actually just getting tired. I'm just reading this same line and it's making no sense to me. Please tell me in the comments. I'll read it later. But yeah, you can do that big line, and I'm gonna let you do it yourself because I'm lazy. Another assignment, don't forget to do that. Next, chapter survey, don't forget to do that too. And then the last section is the command line review. So we have a theory called spaced repetition. So something I have heard of. I guess I've done it in the past, but not really thinking about it. But instead of just cramming everything all in one go, sort of do little bits again and again and do more of it. The slow but steady approach to spaced repetition can scale to memorizing hundreds of thousands of items, while crammed items are almost immediately forgotten, and it's especially useful for foreign languages and medical studies. Yeah, so don't just read everything, try and get it over your head. So like even this video, like this is pretty long, this is a lot. So yeah, don't stress, just do a little bit, take a break, come back. Do a little bit, take a break, come back. And definitely just practice more and more. Great, and that is gonna do us for the Linux command line section of the Computing Fundamentals course. I hope you've enjoyed this course so far. I'm very much enjoying it, going through it again. Must admit, it is a lot easier, the fact that I've gone through it before, but it is still a lot to get through, I must admit. It's a big course, so take your time, take breaks, spaced repetition. Otherwise, consider subscribing. I hope you've enjoyed the video. If you have any feedback, please let me know. Feel free to leave a like, let me know that you enjoyed the video. That means a lot, helps the channel, helps me, helps motivation, all that sort of good stuff. Otherwise, thanks so much for getting to this part of the video. I really do appreciate it, and I will see you in the next one.